Good morning, everyone. Welcome to Megger webinar. I'm Grace from Megger Hong Kong. I'm the marketing manager for Megger Asia, and I'll be the moderator today. Today is a live webinar. You automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question box, which you can see on the left of your screen. We will answer questions in the Q&A session. At the end of the webinar, please have a fill in the survey, which you can see on the right-hand side. We'll be sending the presentation materials to those committed the survey. You'll be able to download an attendance certificate after you have finished the webinar and completed the survey. And the recording of this webinar will be sent to you in 2 days' time after the webinar. Today, our topic is actual demo of oil testing using Megger OTS Insulating oil tests, presented by our Megger Technical Support Group leader, Michael, Evangelista, and our application engineers for transformer segment, Mr. Smit. Next slide, please. Let me introduce our speakers. Michael is the East Asia Technical Support Group Manager for Megger. He started with Megger in 2016 as application engineer. He has a broad experience in different electrical applications and is appointed as the product champion for transformer testing. He's also a registered electrical engineer, an active member of IEE of the Philippines, and a member of IEEE. He is also a co-author of a technical paper entitled Optimization of Power Transformer Insulation Throughout Process using Dielectric Frequency Response CFR, which was published in November 2022. Over his 19 years of experience in transformer testing, relay, and scatter, Michael has contributed a lot to the electrical industry. He enjoys sharing his knowledge and experience through technical presentations and is always invited as guest speaker for many industry events. Our next speaker is Smit. He is the application engineer for power transformer segment. He's an HSARP has started Megger this year, and he's also former being part of Megger distribution company, and having worked in a power plant in Thailand, has equipped him with extensive experience in the field of transformer testing. He's visionary and aims himself to be expert in advanced transformer testing and diagnostics. He also part of the global transformer team to facilitate and promote the innovative 1 Hz transformer testing technology in the region. So let us pass the time to Michael and Smit. Thank you for joining us today. Michael, Smit, are you ready?
Yes, Grace, thank you so much. Can you see my screen in full screen, right? Can you
Yes.
see my slide in full screen? All right. So good morning, everyone, and welcome to this webinar. So today we're going to talk about the OTS. But before going to the actual demo, as the title of this webinar is, I want to review first. Let's review first what is the what are the reasons why we use the oil, for example. So normally, for using oil, we use it as an insulating medium for transformer, for any electrical apparatus, and also it is used for cooling by circulation. So it serves as coolant also. But of course, we are not talking of these oils. These are the cooking oils, the engine oil. The oil that I'm talking about is the oil for electrical apparatus, like for transformer, distribution transformers, and some reactors, circuit breakers, cables, bushings, and capacitors. So normally, we are talking of this electrical apparatus oil. Okay, so any type of oil, as you can see here, it includes the FR3, EnviroTemp 200. So we can test those types of oils. Now, according to IEEE C57.106, these are the guides for oil acceptance. So when you accept oil, for example, you need to conduct electrical test, physical test, and chemical test. And these are the common oil testings. For electrical, we do the electric breakdown, dissipation factor, the resistivity, and when we do the chemical test, of course, there is the dissolved gas analysis, water insulating liquid like KF Love, and also for physical oil, physical test. I mean, we do just the color check. So as you can see here, as the oil getting darker, it became bad. So today we will be talking about the electric breakdown voltage. So what types of insulating oil can be tested? So during the dielectric breakdown, with the dielectric breakdown, we can test mineral oil, high molecular weight, hydrocarbon fluids, silicon fluid, synthetic ester fluids, and natural ester fluids. So those are the oil that we can test with the breakdown voltage. So when and why we do this dielectric breakdown test? Okay, dielectric breakdown is actually to measure of the liquid's ability to withstand electrical stress without any failure. So meaning we are injecting high voltage and see how the oil uh, performs, or the quality of oil, to check the quality of oil using the high voltage injection. And this is to check the presence of contaminating agents in the oil. So why breakdown voltage? Because it is the easiest and quickest way to test the oil for detecting the moisture and contaminants, predicting remaining transformer life, of course, maintaining equipment safety, fire prevention, maintaining reliability. So this is the primary reason for testing oil sample from high voltage equipment. So when we are talking of high voltage equipment, the primary reason of testing the oil is that to look the aging of the oil, and also to check if we have some contaminations like moisture, chemical contents, solids and particles, and condition inside of apparatus like if we have some arcing, overheating, and other damage. So these are the primary reasons for high voltage equipment oil testing. Now, if you will ask me uh, how often or when do we need to test the oil for breakdown voltage? Well, Megger strongly recommends that the oil is tested at least once a year and preferably twice a year. Also, for the result analysis, it is recommended that you do the trending. Okay, so like on this graph here, of course, the ideal scenario is you have a flat line. So from this curve here, you will see that on the 8th year or 7th year, the oil is starting deteriorating already, and by the 8th year, you can see the sudden drop. So this will all this will already give us some information that we need to take some actions on that oil. Now, talking about the standards of oil testing, we do have different standards or applicable standards. We have the ASTM 3487. This is the standard specification for mineral insulating oil. We have the IEEE C57.106. This is the acceptance. We have the ASTM D923, the standard practices for sampling. So normally, if you do sampling of oil, I do really suggest or recommend that you must follow or comply with the ASTM D923. Okay. And there are there are three popular standards now being used to test the electric breakdown voltage. That is the ASTM 877, wherein it uses this electrode, electrode here. We have the 1816, which uses the VDE electrode or the mushroom type electrode here. And we do have the IEC 60156-2018. So when you check our datasheet, it will tell you, you will see the summary of the standards and the required gap, the required impeller, the required voltage rise. So these standards are available with our OTS tester, okay, the oil tester. So now for the testing procedure, of course, we need to follow some standards and we need to follow some step-by-step procedure. So normally when we do the electric breakdown voltage test, we of course we do the sampling first, and that sampling should comply with a specific standard. And then after sampling, we do the testing. And during the testing, we need to select the standards that is applicable to our application. After the testing, we need to validate if the test results are valid. We just don't, assess immediately the result without looking at the validity of result. Meaning, when I say validity, we look into the repeatability of the test, right? Because most probably, or maybe sometimes you will experience that you got this voltage and then you got, for example, let me try to use the pen here. For example, the first breakdown is 10 kb, and then the second breakdown you got, for example, 50 kb. So this is not acceptable. Why there is a sudden jump of, there is a sudden increase of the electric breakdown voltage? So meaning, most probably, when you do the test, if, for example, you are using the BDE, right? So most probably, during your first test, there is some particles, floating inside that causes the electric breakdown to have this low voltage. And then suddenly, this one goes below or drops down, so you can have the 50 kb. So meaning to say, your test is not valid because, you don't have any homogeneous situation. The oil is not really, clear to test. So after the validity, once the test is valid, then you can go to the assessment or check for the limits from the standard. So that is the proper procedure. And we will show it later in our actual demo. Okay? So for the oil sampling, I recommend in the US, there are two standards for sampling. This is the D9223, D3613. And internationally, there are two further sampling standards. We have the IEC and so on. Oops. And talking about 877, we have, as I've said, we are using this electrode here, and normally the spacing is 2.54. But on our actual test later on, we will use the 1816, wherein we use the VDE electrode. We have the spacer or gap spacer, which is, we normally use the 2 millimeter or 1 millimeter. Okay. So to me, the 1816 is more strict when it comes to testing of oil, because it has a 1 millimeter gap. If you wanted to use that for newly delivered oil, then I suggest you use the 1816. So it actually depends on your application, right? And when we use the IEC 60156, you can see the here, this is the electrode used by the IEC. You have the magnetic bead stirrer, and you can also use the BDE or mushroom type electrode for the IEC. So remember, we are talking of testing here, right? So when you do the testing, you need to select the proper or the correct standards to use. Okay. Now, for example, if you've done with the testing, of course, you need to validate your test results. So when you validate the test result for 1816, it says that if breakdown does not occur in 1 or 2 millimeter, then reduce the gap to 1 millimeter. And test must be repeated if range of breakdown voltage recorded are more than 120% of the mean with 1 millimeter electrode gap, and 92% of mean with 2 millimeter electrode gap. So later, I will explain more when we show the example test results. So for 1816 here, test must be repeated if range of breakdown voltage recorded are more than 92% of the mean value. And if range of 10 breakdown voltages is more than 151, investigate why. For the IEC, we use some graph, expected range of standard deviation divided by the mean ratio as a function of the mean provided as a chart. So we're using the chart, and I will explain later. The 1816, as I've said, use 1 millimeter gap. If you are using 1 millimeter gap, then the range must be less than 120% of the average value of 5 breakdown. If you are using 2 millimeter gap, the range must be less than 92% of the mean value of 5 breakdown voltage. So in this example here, okay, so as you can see, we are using the 1816, right? And the mean value or the average value is 43.3 kV. This is the one that we are going to use to check with the limits. Okay, this is the value that we are going to use later for the assessment if the oil is okay or not. But we need this to compute for the testing validity. We are talking yet of validity of test. Is it okay to go with the limits? Now the range here, as you can see in the display, is 10.1 kV. Where did it came from? It came from the highest value we got. So in this example, we got the 47.6, right? Minus the lowest breakdown voltage we got, which is 37.6. So 47 minus 37, that is our range, 10.1 kV. Now, this result is passed. It doesn't mean that our oil is good. We are just saying here that our testing is good. The way we tested it is okay. This is just a test validation. This is not referring to the oil quality. Okay? So that is how it is. Okay? So again, the 877 have this criteria. Number of breakdowns 5, the range is 92. And if the condition above failed, for example, if the 5 breakdowns still the test validity is failed, then you need to continue with the 10 breakdown voltages. But you need to increase also the limits of testing criteria. Just the testing criteria, not the oil criteria. Okay? So the range must be less than 151. What is the range again? This is the maximum minus minimum voltage we got. For the IEC, it's very, how should I call this? Complicated. Yeah. So in the IEC standards, a lot of people asking me on how to assess this one. So this is how to assess this. For example, if you got 6 breakdown here, right? You need to get the average, which is the 64.16 kV. You need to get the standard deviation. So I believe everybody knows how to get the standard deviation in Excel. It's very easy to get the standard deviation from Excel. So this is the standard deviation here. Now, we have a thing called coefficient of variation, which is standard deviation divided by the mean. So meaning this value divided by this value, you will have this value, 9.83. Now, this is the graph of the coefficient of variation. This is just an example. You will see this one from the standard, but this is not, this will be based on your actual testing. This graph will be based on your actual testing. All right? So in this example here, if for example this test here, we got this graph for this test, then we need to find the value of the coefficient of variation and the main breakdown voltage. So remember, our mean breakdown voltage is 64 kV, so it falls under this line here, right? and our standard coefficients, which is around 10%, then it falls under here. So meaning to say you have this point here. Now, this dotted line corresponds to tolerances. This dotted line also corresponds to tolerances. This is your actual standard deviation graph. So as you can see, this dot falls under tolerances. So within the tolerance, so meaning to say, the result or the test is valid. You can go on with the assessment limit because it falls under or it falls inside the tolerance. Okay? This is just an example. Graph is just an example for reference only. Of course, different result will display different graph. So this is the IEC 60156. This is how you analyze or this is how you validate the test. So this is looking at the repeatability only. Because for example, the dot falls over here, then meaning to say you need to repeat your test. There must be something wrong with your oil. Maybe there are some contaminants flying that passes through the middle of the electrodes. So it's not correct. You need to repeat the test. But on the other procedure, you need to continue the test with the, if I'm not mistaken, add additional 6 breakdown to have a 12 breakdown. If I'm not mistaken. Okay. All right. So now that we know that our test is valid, then now we can do the result assessment. So according to ASTM D3487, if you are using 877, the mean breakdown voltage or the average voltage should be at least 30 kV for a received new oil. And for 1816, if it is a received new oil, then 20 kV. Remember, this is 1 millimeter gap only. That's why it's lower because it's 1 millimeter. But when we are talking of 2 millimeter, the requirement for the new oil is 35 kV. That's why I said it's much stricter, right? Look at this, 35 kV and 2 millimeter. Remember, the 877 is using 2.54 and only required 30 kV for a newly received oil. All right, that is the limits. These are other additional limits for 1816. So this one depends on the type of, condition of insulating oil. So we have, for example, if it is a newly material, so this, anyway, we will distribute this, we'll give the copy of the presentation to you, so you can refer this one if you don't have the copy of C57.106. All right. So for IEC, this is the limits for IEC. If it is more than 72.5, then you got more than 40 kV, then it is good. But if it is 30 kV below, then it is bad. So this is based on IEC 60422. All right. So now we know the limits. Let's go on to our test equipment. Maybe I'll skip this one and we go over to the actual video. But you already know that we have Megger. We and Megger have these products. We have the portable one. Oh, by the way, what is the reason why we are offering portable one? Remember that when you do oil testing or the electric breakdown voltage, you need to test the oil within 8 hours. Okay? So these portable units offers the convenience of testing the oil at site. So meaning after you extract the oil from the transformer, you can test it right away. So that, you can avoid, contaminating the oil after taken out from the transformer. You can test it right away with the portable units. And the good thing with our portable units, it is a battery operated, so you can also charge it using the car charger. So it's good. And as you can see here, this is the OTS range. You can save the result in the USB. Easy to clean up. There is no sharp edges here. It has temperature sensor. Look at the edges. It is protected with a rubber footing. And it's not heavy. It's lightweight. You have a drain bulb here, or the drain. Uh, you have the printout, of course. And look at the baffle here. No mess, because before we are using this one and some oil is sitting on this area. In this case now, the new baffle offers the, it's very closed. I mean, no, no, no empty space that oil can go through. So this is the new baffle. It's fully covered, and we have different impellers. The red one is used normally for a dirty oil, or a contaminated oil. So we need to mix it. And we have also the spacer. As you can see, this is the spacer here. It is a black anodized coated, meaning to say it has coating. So when you start to see some silver color here, that means the accuracy of that gap is no longer correct. I mean, the accuracy is no longer accurate. So yeah, this is the black anodized coating. When you see some silver, then it's not accurate anymore. We also have some checker for calibration, and we have the portable one. We also have the laboratory one. So the difference is that this keyboard for the portable one. Okay, so let me check with the time. Yeah, now we can go. You can also buy this casing if you wanted to for travel. Uh, it's very easy to read the result because it is automatically printed out. But you can also view the result in the screen if you want. You can also view the result by importing the SQL file to PowerDB. So later on in our video, you will see. All right, so now let's do the hands-on. So this is actually a pre-recorded video yesterday due to the difficulty in setting up the laboratory. So let me try to play this video, and you can start to ask questions if you have in the chat box, guys. All right. Uh-huh. So first you will. Yep.
First of all, when we do testing of the oil, we will use the globes. This type of globe should be not a normal rubber globe, because if it is a normal rubber globe, that means you get some powder or some particle on that globe. It should be medical globes or food grade. Okay, so after we got the gloves on your hands, you can choose the standard for testing. From here, you can see our accessories. The spherical, we have the machine type, and we have the square spherical one. And we can choose that will be touched with the
Hi, Smit.
volume that we are going to test. We have to make
Smit?
sure that
Yes.
no
Can you just do the voiceover of this one? Because I think it's a little bit laggy here.
Okay, sure.
All right, so let me turn off, and then I'll continue to play. Okay, just do the voiceover.
Slack.
So let's go to the where we are now. Yeah, this one here. Yep, go ahead, bro.
Yep. Okay, this is the adjusting the gap of between the electrode. We can use the spacing or the gap adjustment, which this one has been designed for adjust perfectly because On the adjuster, it has been coded with the black color, but actually the material color is the silver one. So that means if you found some scratching or the thickness of the gap has been changed or has been scratched out, you will notice it easily. And when you Michael, I think the video go too fast. Okay, this is for the cleaning, and you have to rinse carefully, slowly, so do not create any bubble or let the air goes inside of that vessel. And any part of the vessel that will be touched or contact with the insulating oil, you need to rinse it. Even the lid or the impeller and the electrode, everything. Yep. And after we rinse, we will put the oil inside the vessel slowly so that the level of the oil is higher than the limit that has been controlled. For normal standard is 400 millimeters. And we should top up a little bit higher than the limit, because when you put the lid over the vessel, it will press the oil to overflow a little bit out, so that when we are testing, the air will not contact with the oil. Okay. And inside the OTS, you can see that we have a silver button below of the vessel. That one is for the temperature sensor measurement. And we have to put the impeller inside before and clean too. And you can see from the video that after I push the lid over the vessel, it will make the oil inside overflows out. And we have the drain hole over there. If you get the new OTS, there are two types of the cover or the lid. The one is with the baffle, and the other one is not with the baffle. That one is for closing only, not for testing. And we can set up the testing standard from this screen. You can select the testing standard, test ID, the type of the oil, the gap. And we have the main 6 menu. The first one is home. We have a lot of the standard right now, such as the ASTM D1816, which current version is -19, and the ASTM D877, which currently they don't recommend to use it anymore from the latest version. And the IEC also have the current procedure and also have the improved procedure for reducing the scattering of the testing result. we can choose it, which one that we want to use it according to the design of that insulation oil. You can choose that you want to use the stirrer or not, or the type of the stirrer to be impeller or the magnetic beam.
So would you like me to continue, Smith? I can take it from here.
Yeah, okay.
Yeah.
Because
so guys, as you can see, Smith is setting the testing. Okay, this is the test setup wherein you can select different standards. So there is a way, if you don't want to go over with those standards and just go directly to the standards you have you wanted to, you can actually set that one in the tools, and then you can select the standards that you wanted to use, so that when you press the OK button, you cannot go over to those standards listed. And so as you can see, we got the unique test ID. You need to put some unique test ID for you to for easy access or for easy saving. And now this is the testing proper. So as you can see here, we have some settling time. So when you use the ASTM 1816, there is a required settling time of 3 minutes before the actual voltage injection. So let's do the fast forward.
Okay, and this is the end of our testing.
So yeah, that's the end of the testing. Now the result is automatically printing after the test. But you can also set that one to save the paper. For example, if you wanted to save the paper, you can actually set that one to not to print automatically. Okay, but I guess the default is printing automatically the result. So after that, you can also view the result from the screen if you don't want to print this paper. So Smith is doing the viewing of result in the screen. So then the OTS will give you option to save it, print it, or to go over on the results. So it's very detailed here. You can see the mushroom type, the electrode type, the gap used, the oil type, if it is mineral or silicon, stirrer type, the maximum voltage setup, the temperature. Remember, we have this temperature sensor inside, the standard deviation, and the range, that is maximum minus minimum, that is 4.6 kb. It's too low. And yeah, as you can see, the 92% of the average is 11 kV. That is the 92%. So remember our criteria for testing validity. It should be more than, if it is more than 92%, then we need to, the testing is failed. You need to test again. So here, the test validity is passed. But again, we are not referring to the oil breakdown voltage. Later on, using this mean value or the 11.9 kV, the value of the mean voltage, we will use that to check with the limits according to the standards. Okay, so here the result, as you can see, pass because the testing is valid, meaning that the methodology. So remember, just to remind you again, for our procedure, after sampling, we do the test, but we need to validate the test before we go to assessment. So this pass means our test is valid. You can make use of the mean value for the limits assessment after. So as you can see, the OTS is actually uh, automatic or automated. So you don't have to compute because before you need to compute, oh, what is the 92% of mean value, something like that. This one is automatically computed and assessed automatically. Okay. So after that, after viewing the result, then we can also save the result using the USB. Save it into the USB.
Select the destination that we want to save USB, and using file name, set up the file name like D1, and we will select the test result that we want to save or export. Okay, so here's the file T1. Okay, you can see that there is a file type is SQL. Here, this file type we cannot open if I don't use the reading. So when you save, you have to choose carefully that this is correct one or not. If I choose the SQL, let's copy to this screen. I will open the our DB. Okay. Okay. So here you can see the testing screen of very nice our DB about to show the OTS. We just click import the OTS file. You can see that you can import both the SQL or the CSV file. So means you can choose both. Let's stop, just SQL, open. There is a testing ID here. Just click OK. So in this form, there is a instrument type, but you can put your customer name like Megger, address, Bangkok, or anything here, and be the real one, 36. And you can see the testing result ID, the date, vehicle type, anything that you have already put when you did a real test before. And here is also the result. We have 5 times of the breakdown, and the validate is passed, but the actual testing result is not passed. So
you can put comment.
And we can put the comment here that the validation is good, but it's big.
Okay, so that is the video, guys. So normally when we perform the breakdown voltage test, we go to the home screen, select the standard, input test ID, select the electrode shape. Sorry. Home screen, standard, and input test ID, select the oil type. So actually the oil type here will depend on the standard that you are using. Of course, for example, the ASTM 1816 is only valid for mineral and silicon oil, then that is the only option you will have there. You can select the gap that you have used. So you can also select the electrode shape and the stirrer, and you can run the test. That's how simple it is. Okay, guys. So I guess if you have any questions, we are ready to answer your questions if you have. And you can contact us on these contact details. You can contact Dr. Diego Robalino if you want. He is our Global Industry Director for Transformer. We have Elmer A. Austria, our Regional Sales Manager and the Transformer Segment Leader. And also yours truly, Michael Evangelista, and you can also contact Smit Lertsethawanich. So, Grace, do we have any questions from the chat box?
Yes. So thank you, Michael and Smith, for your presentation. Now it comes to the Q&A session. If you have any questions from the audience, please type into the chat box. Our panelists will answer your questions. And for those of you who are leaving, please have up to fill in the survey, which is very important for improvement. And also, after you finish the survey, please also download the attendance certificate, which is at the bottom control panel on the right-hand side. So I guess some of the questions have already been answered in chat box. While you're still typing in your questions, let me remind you that we'll be having 2 more webinars in December. The first one is next Thursday, 7th of December. Topic is condition assessment of different assets in wind power installation by partial discharge diagnostics. And the next one is on the 14th of December, relay protection strategies and test challenges in wind farms. The time for both webinars are at 10 o'clock in the morning, Hong Kong time. So if you're available, please go to our website, www.megger.com/webinars to sign up for the webinars. So please take some time to give it your questions. Michael, we have a questions just come in. Should I read them out?
Yes, Grace. Yes.
Okay. This question is from Joseph C. asking, what would you recommend if our national standard follows IEC 6156, which requires rinsing with the sample before filling the vessel, but we test all circuit breakers on site with a limited volume of oil to sample?
What would you recommend if our national standard follows IEC 60156, which requires rinsing with the oil sample? That is really required, sir, because normally, for example, you have a test vessel coming from the cabinet or something. It might be contaminated, or it might be, there are some other particles on it. So you need to rinse it with the oil sample to be tested, but not really too much. I mean, you can just put some small amount to cover all the, especially the electrode and the walls of the test vessel. So normally you are only requiring 400 ml. But yeah, you are right. If it is a circuit breaker, then you have a limited volume of oil. So maybe I would suggest, if you have a limited volume of oil, then maybe you can just do the what do you call that? The tangent delta testing, wherein you don't have to collect oil to extract oil. This is for oil assessments, right? So you can also do the tangent delta testing or the IPF, insulation power factor test, to test that oil in your circuit breaker. But normally, for the oil dielectric breakdown, yes, you really need to clean that with the oil sample. Or if you have a new oil, maybe if you have a better oil, meaning it is new, you can clean up the test vessel with the clean oil. It's okay. Then you can fill it with the oil to be tested. It's okay. You can clean up with a new oil which you are confident that it has no contaminant or other particles on it. You can clean that with that.
Okay,
Is
thank you,
there any
Michael.
question? How to take oil sample with good procedure? Sir, it's in my presentation a while ago. We have different procedure. For the US, we have two different popular procedure. What are the other questions here? Is the only difference between... okay, so Smith already answered this one through chat. Okay. Is there
All
anything
right.
else, sir?
I guess we don't have any further questions at the moment. But if you need more time to think about the questions, you can always send us email to ea.marketing@meggerea.com. Just a reminder, please fill the survey and download the certificate, and we'll be sending the presentation materials to those committed the survey. And also, the recording link of this webinar will be available in 2 days' time. So if there are no more questions, thank you very much for attending. And thank you, Michael, Smith, and also Bernardo and Smitty. We hope to see you again next week. Thank you very much, everyone. Bye-bye.
Thanks, everyone. Bye-bye.
Thanks,
Thank you,
everyone.
everyone.
Bye bye.
Bye bye.